Crunch time approaches. Scientists reveal terrifying details and exact timeline of the universe's big crunch end scenario. From alien invasions to robot uprisings, there are countless apocalyptic scenarios imagined for the end of the world. But now, scientists have taken a terrifying step further by calculating when the universe itself could meet its ultimate demise through the Big Crunch, a cosmic collapse that could bring everything back to singular point, wiping out all existence as we know it. Let's unravel the full story in today's AI podcast Deep Dive.
We're all kind of fascinated by the end of the world, aren't we? You see it everywhere, alien invasions, rogue AI in movies, that sort of thing. But what if the real end isn't like that at all? What if it's something, well, bigger, more cosmic, something scientists are actually predicting? That's what we're diving into today, a theory called the Big Crunch. And our mission here is to unpack this idea. It's a pretty startling theory from cosmology, suggesting the universe might collapse. And what's really wild is that some scientists think they know when it could start. We've been looking at research from some really serious physicists, teams from Cornell, Shanghai Jiao Tong University.
That's right. And this isn't just, idle speculation. It's actually based on new measurements, fresh data about how the universe works. It suggests everything we see expanding now could eventually reverse, head towards this ultimate implosion.
Okay, ultimate implosion. That definitely paints a picture. But let's back up a bit. What exactly is the Big Crunch, in simple terms? How does it connect to the Big Bang?
Right. Well, think of it like running the movie of the universe backwards. The Big Bang, as you know, was this massive expansion from a super hot, super dense point. The Big Crunch it's the opposite. The universe stops expanding, maybe, and then starts to contract. Everything gets pulled back together. Galaxies, stars, all matter, crushed inward until it all returns to an incredibly hot, incredibly dense state, a singularity, much like how it began.
A singularity, like the beginning, wow.
Exactly. A point where our current understanding of physics might just break down.
So what makes it switch? You mentioned expansion now, contraction later. What forces are involved? Is it really like a cosmic tug of war?
A cosmic tug of war is actually a pretty good analogy, yeah. On one side, you got this thing we call dark energy. It's mysterious. We don't fully get it, but it seems to be pushing everything apart, accelerating the expansion.
Okay, the accelerator.
Right. And on the other side, you have gravity, or more technically, what these researchers are calling a negative cosmological constant, basically the universe's own tendency to pull itself back together.
Gravity versus dark energy.
Exactly. And for a long time, the thinking was, well, dark energy is constant, it's winning, so the universe expands forever. It gets cold and empty. But this new work, citing Professor Henry Tai, Dr. Hongnan Liu, Dr. Ethan Yu Chang, suggests something different. Their data implies dark energy might not be constant. It might be weakening, fading even.
Wait, fading. So the balance could shift.
Precisely. If dark energy fades, gravity eventually wins the tug of war. Expansion slows, stops, and then reverses into contraction. That makes the Big Crunch not just possible, but maybe even likely. It's a huge shift in thinking.
Okay, that is huge. If this contraction is likely, then when? Are we talking soon? I mean, cosmically speaking, what's the timeline?
Right, the timeline. It's vast. According to their calculations, the very first, very subtle signs that contraction is beginning might show up around 11 billion years from now.
11 billion years. Okay, not exactly tomorrow.
Not at all. And the actual collapse, the final crunch back into that singularity, that's projected for about 19.5 billion years from today.
So if we add that to the universe's current age, about 13.8 billion years.
You get a total lifespan for this cycle of the universe of roughly 33.3 billion years. We're roughly, 40% of the way through?
It's still just numbers so big they almost lose meaning.
Yeah.
Billions of years. How can anyone even notice changes that slow? Would we even detect it happening for ages?
That's a really important point. The initial stages would be incredibly slow, imperceptible on human timescales. Dr. Liu put it well. He said something like, civilizations last hundreds, maybe thousands of years. The Big Crunch plays out over billions. So no, we wouldn't notice anything obvious until things were really, really far along. The confidence comes from the physics models and these new refined measurements suggesting dark energy isn't fixed.
Okay, so it creeps up on the universe. But eventually. Eventually it must become noticeable, right? What would those later stages look like? Feel like even?
Oh, absolutely. Eventually, the signs would be unmistakable and quite dramatic. First, you'd see it in the sky. Instead of galaxies rushing away from us, the red shift we see now, they'd start showing a blue shift, moving closer. The whole expansion just visibly reverses.
So the night sky would start to look denser?
Over immense timescales, yes. And maybe more critically, the universe would start heating up. Right now, expansion cools everything down. The cosmic microwave background radiation is evidence of that cooling. Reversing that means heating, slowly at first, then accelerating.
How hot are we talking?
Well, the research suggests that about 13 billion years from now, the overall energy density of the universe could be 1,000 times what it is today. Then, just maybe 500 million years after that, it jumps another 1,000 times. Space itself would be like room temperature.
Room temperature everywhere.
Everywhere. And it doesn't stop there. Soon after, the entire cosmos heats to the surface temperature of the sun, then keeps going all the way up to the Planck temperature, which is basically the theoretical maximum temperature possible in physics, higher than the center of a star. It's, well, the paper calls it a furnace of cosmic hell. Everything just burns.
A cosmic furnace. That's terrifying. And what's gravity doing during all this heating and shrinking?
Gravity becomes completely dominant. As everything gets closer, its pull gets exponentially stronger. Planets, stars, they drift closer, merge into bigger and bigger objects. Eventually, matter itself gets squeezed down into spaces smaller than atomic nuclei. It's hard to even picture.
What about things like black holes?
They might hang on for a bit. They'd actually grow enormously, just feasting on all the matter collapsing around them. But even they aren't permanent. In the very final moment, everything, the black holes, all particles, all energy gets forced into that single, infinitely dense, infinitely hot point, the singularity.
And that's it. The end of space, time, everything.
As we know it, yes. The absolute end.
It really puts our existence into perspective, doesn't it? Thinking about humanity's place on this cosmic clock.
It does. And the key thing to remember for us right now is that this is all incredibly far off. Billions and billions of years. As Professor Tai pointed out kind of dryly, humanity almost certainly won't be around to see any of this.
Yeah.
We have more immediate cosmic concerns.
Like what?
Like our own sun. In about 5 billion years so, much sooner than the earliest signs of the crunch, our sun runs out of its main fuel. It'll swell up into a red giant. It could very well engulf Mercury, Venus, maybe even Earth.
So our planet might be toast long before the universe itself collapses.
Very possibly. After the red giant phase, the sun shrinks into a white dwarf. That's the end of our solar system as a habitable place. So if humanity is still around in 5 billion years, we'd need to have already found a way off Earth out of the solar system entirely.
Is that a more pressing deadline, I suppose?
A bit, yeah. Still distant for us day to day, but cosmically much closer.
Even so, thinking about the Big Crunch itself, the implications are just staggering. It changes the whole narrative of the universe's future.
Absolutely. It sounds like pure sci-fi, but remember, this is based on the same physics we use to understand stars and galaxies right now. It's just applying it to the biggest scale possible. And it creates this incredible, almost poetic symmetry, doesn't it? The universe beginning in a fiery point and maybe ending by returning to one, not fading into cold darkness, but collapsing in a final cosmic crush. It really makes you rethink everything.
It certainly does. We've gone from the earliest hints, 11 billion years away, to that final unimaginable furnace 19.5 billion years from now. It's a lot to take in.
It is. But the takeaway for now, we have time. Lots and lots of time. Time to keep looking up, keep exploring, keep asking these huge questions. And who knows, maybe even find other places out there among the stars before the universe decides to call it a day. Something to think about anyway.
Okay, do you think collapsing universe could create a loop of time and leading back to the beginning? Don't forget to comment it. Thanks.